I recently participated in the GMTK Game Jam 2023, an event hosted by Mark Brown from the GMTK YouTube channel. I wanted to step it up a level by not just making my own game, but also my own game engine. People often use an existing game engine because it provides so much for you. You can just focus on making the game that you want to make. But I wanted to challenge myself to create a game without using an existing game engine or framework. Creating a game engine is a huge effort and there's a lot of stuff that you can do. I'm not going to implement everything, but I'm going to make sure that it's at least kind of cool. So the game jam's just about to start and the theme is roles reversed. So the only good way to start is by first making a hello world program and making sure it compiles. Then to easily build my project, I make a CMake file. So I started with the most basic feature, which is the ability to have a window. So now I have one and I can move it around. To draw stuff on the window, I have to add OpenGL to the project and create an OpenGL context for that window. I need to specify some OpenGL libraries to link to and add a game loop to handle the inputs, to update and then to render. Okay, so let's talk a bit about OpenGL. Let's say you have 3 points that form a triangle. You could store that in memory in what's called a buffer. You can also write some code that's called a shader, normally written in GLSL, that when you send the shader and your buffer to the GPU, it will render the triangle colored in the way that you specified in the shader. This is a simplified explanation, but you're going to see that I'm going to write code that sends buffers and I'm going to write shaders in GLSL. I create points in 3D for a triangle and put them in a buffer and send that to the GPU. I write 2 shaders, one that just passes data through and the other one will color the triangle orange. I tell CMake to properly copy these assets to the build directory. To use these shaders, I have to read the contents of the file, and then I decided to open CLion and make a class for shaders because I'm going to have many different shaders and I want to be able to reuse this code. After reading the contents of the shader, I have to compile it, then link it to a shader program. So of course the project doesn't compile and nothing works. So I fix all the bugs and eventually it works. I finally have a triangle, it's orange, and I'm super happy. But now it's 2:52, so I've already been at this for 2 hours. After one triangle, the goal is 2 triangles. My 2 triangles are orange, but I don't want my entire game to be orange, so I make a texture. A great resource is learnopengl.com. This is a site I had open on my second monitor for most of the jam. So now I had to load the PNG file, create a texture and send it to the shader. Unfortunately, it didn't immediately work, so I had to spend some time solving the bug, but then it worked. Since I had no idea what I was going to actually make as a game for the game jam, I decided to keep my code clean and make a texture class in case I have many textures. Now I wanted to see something moving on the screen, so I decided to rotate this quad. After 4 hours of work, this felt super satisfying. Just for fun, I decided to create a spinning cube. Even though the textures are messed up, it doesn't matter. Up to now, I had specified every vertex on the mesh. I wanted to load my own meshes. So I added a simp to the project. This library allows me to get vertices and normals information from OBJ files. So I can make a model in Blender and then export it to OBJ. So let's talk about what I use to make my game engine. So I use C++ as the programming language. Then I used CMake to build the project. I used SDL to create a window, OpenGL and Glue as the graphics API, GLM for math, STB image to load PNG files for textures. I used a simp to load OBJ files for models. Later on, I used Python, and I used NumPy for math, OpenCV for image processing. You might be wondering what OpenCV is doing here, and that's a good question, but you'll have to find out later. Let's talk about lighting and shading. So let's say you have an object and you have a light source. The light source is sending a ray to the object and the ray bounces on the object. Depending on how the ray bounces, there's going to be an angle. The smaller the angle, the more direct the ray is on this object, so the brighter the object should be. The bigger the angle, the darker the object should be. What I just said was a simplification of the Phong reflection model, which is what I'm implementing in the engine. I spent around 2 hours on this. It's mostly shader code, and I decided to add the actual light in the scene and make it rotate around the model I imported. I was really satisfied with this. If you look closely, you will see the specular reflection. It's been over 8 hours since the jam started, and I still have no idea what I'm going to do as a game. Recall that the theme is roles reversed. So I started writing some ideas in a document. All my ideas were pretty bad, so I just went to sleep. I woke up the next day and got to work on finding an idea. I wanted to find my idea as soon as possible. I ended up picking golf, but you play as the whole. So the first thing I wanted to do was to model a golf ball in Blender and then import it in the engine. I don't have much experience with Blender, so this took me some time. Eventually I had a golf ball and it looked pretty good. I really like how it looked with the specular reflection. So I went back into Blender and followed some tutorials to do something nice with the terrain, but I ended up doing something really simple. So I knew I wanted my game to have uneven terrain, I wanted some hills, and I wanted the ball to be able to roll down the hills. But due to time constraints, I decided to not make the ball bounce. So this game is like mini golf. So since the ball would always be on the ground, I wanted to export height data from Blender. I wanted a height field so I would know where to place the ball on the terrain depending on the height. Let's talk about physics. So let's say you have a ball. In what direction will the ball accelerate? So if you said something like this is a good answer and you could get it from the derivative. That's in 1 dimension. In 2 dimensions, you would get it from the gradient. It turns out you can get the gradient of an image. So earlier when I said I wanted the height field as an image, it's because I want the gradient of the image so I know how to accelerate the ball on this terrain. To do this, I used OpenCV, a library I've used in the past before, but for some reason I wasn't getting the results I was expecting and my motivation was really low, so I just decided to take a break for an hour. I went to eat, I went for a walk, and I just needed a break. Back from my break, I felt so much better and was much more productive. I implemented the terrain data in the code and I wanted to see if the ball would actually follow the terrain. So it was kind of working, but there was something that wasn't quite right. Eventually I found the problem, so Blender did not account for gamma correction when I exported the height field. So with that out of the way, I implemented the physics using the image gradients that I got from my Python script with OpenCV, and I tried it out. It needed a bit of tweaking, but I was pretty happy. Now I wanted to simulate a hit from the putter to the golf ball. This consisted of just setting an initial velocity to the ball. There's maybe a bit too much friction. Before the ball got hit, I wanted to show the player where the ball would go. So I started by modeling an arrow, but then decided that having points trace the path that the golf ball should take in the future would be much more interesting, so I had to predict the ball's position in the future. I want you to look at the red point. Those are supposed to be 8 points tracing a path, but they're all stacked together. So that's a bug, and a really difficult one, so I opened RenderDoc, which is a graphics debugger, and it told me that the position was 0, 0, 0 at all of those 8 points. Eventually I figured out the problem. It was just because I was missing this line. I now had the red points showing up in the game. I could now predict the future. I simulated the 30 next frames of the game and traced the path that the ball would take in the future and added points there. So I also added a model of the hole and I just moved it around to make sure it worked with the terrain. Of course it's too big now, so I'll make it smaller, and then I want to add a flag. I started working on the flag. I opened Blender and proceeded to model the world's best flag model, and then I added it to the game. At this point, I had something decent. I had a ball rolling with some physics, I had a flag moving. I was split with a choice. Do I make this game better by spending time trying to make it fun, or do I spend the rest of my time adding shadows? The choice was easy. I added shadows. Let's talk about shadows. So let's say you have a light source and you have a camera. This is where you view the world. And you have an object in this scene. So how do shadows work? The trick is to place a camera where the light is and render the scene. This means that everything that this camera cannot see is a shadow. So we save this render in a buffer. We don't show it on the screen, and we use the real camera to render the scene and use the frame buffer that we got from the first camera to darken the scene for the second camera, which the player actually sees. So it was about 10 PM when I started implementing the shadows, and one of the key things is debugging shadows is really hard. If something goes wrong, it's really hard to figure out what the problem is, especially in a time-constrained game jam. So I had something not really working, and it was midnight, so I decided to just go to sleep. The next day, I got to my laptop at 8:30. The shadows were broken, the game was non-existent, there was like no mechanics. There was only 4 hours and 30 minutes left. I started slow by making a submission page. Since this is a golf game, I selected the sports category. I relaxed by doing a banner for the game, and then I actually fixed the shadows really quickly. You might not think this looks good, but I knew how to fix this problem and my actual bug was fixed. So shortly after, I had working shadows with a couple small bugs, but I knew how to fix them, so I was really excited. So I fixed a bunch of problems with the shadows, and then I had something super satisfying. Look how nicely the shadow behaves on the hill. Let's watch that again. I wanted to make the game look better, so I first added anti-aliasing to the objects of the game, so you can see before and then after. And then I worked on smoothing the shadows. Again, you can see before and then after. I spent a bit of time working on changing the map, and now it was actually time to work on the game. The way the game works is that the player moves the hole. When the player is ready, the player presses space and the ball rolls, and hopefully it's in the hole. So the player kind of has to predict where the ball will land. I made it so that the ball cannot go outside of the boundaries and that the hole needs to be far enough from the starting position of the ball. If not, you could just put it in front. And I finished the game by adding my favorite feature, a super cool wind animation. So let's look at some gameplay. I never had the time to actually fix the controls to make them good, so they're a bit painful, but I'm pretty happy with how the game turned out. And this game is officially called Portable Par. So I was finished, it was time to submit. I was 30 minutes early, everything was good. Until I see this in the submission rules. I had to build on Windows. I use Arch, by the way, and I wasn't going to build on Windows, so I was just ready to get disqualified. But I talked to one of my friends and he offered to build on Windows, and he built it pretty fast. Due to the thousands of participants trying to submit their game at the same time, the website handling the submissions crashed, and Mark Brown allowed 1 extra submission hour, and during that time I didn't touch my game, but I did have my friend port it to Windows so that Windows users could play. Most importantly, I needed to add the shadows I had spent all morning fixing in the banner of my game.